Hello guys, welcome back to the channel. Let's solve another graph problem today. Today's problem is from LeetCode 210, course schedule 2. So in the previous video, I explained how we can solve course schedule. So in the previous video, in the previous problem, we discussed if we can finish all the courses. But in this problem, we are being asked the order of courses that we have to finish. So there are total number of courses that we have to take, and there's a n number of courses, and they are labeled from 0 to n-1, and we are given the list of prerequisites. For example, if we want to finish the course A, we have to finish course B first. So there is a dependency on the courses, right? If we want to finish course 0, we have to finish course 1 first, then we can finish course 0, right? So we are given this prerequisite and number of courses. Then number of courses, it can range from 1 to 2,000. Just imagine that you have to finish 2,000 classes or courses. And the length of the prerequisite array, each element is 2. And we are guaranteed that all the pairs, AI and BI, they are distinct. So let's look at the example to really understand what the problem is asking. So this is an example. So we are given, in this example, we are given 4 courses, right? 4 courses, and we are given the prerequisites. For example, if we want to finish the course 1, we need to finish the course 0 first. If we want to finish the course 2, we have to finish course 0. And we have to finish course 1 to finish course 3. We have to finish course 2. We have to in order to take course 3, right? So basically, this is as we discussed in the previous problem. This is a graph problem. So this is we need to return the list of the correct ordering that we can take the courses one after another, so that we can finish all the courses, right? So we need to return the list of courses, the correct ordering, if we can finish. Otherwise, we need to return the empty list, right? For example, let's see. If the course, if we want to take the course 1, we have to take the course 0. So there is this called edge. So there is a directed edge from 0 to 1, so which means like we need to finish this course 0, if we want to take the course 1, right? And also course 2 has dependency on course 0, and course 3 has dependency on the course 1 and course 2. So the correct ordering, as we can see, it can be, first we need to take the course 0, right? Then after we take the course 0, then this dependency is broken, right? Then we are free to take the course 1, right? Or course 2, right? We can take course 0, right? Then we can take either course 1 or course 2. We can return in order, right? After we are done, then course 2 or course 1, then we can break this dependency. So course 3, and we can break this dependency too, right? Then we can take the course 3. So we can take course 1, course 2, and course 3, or course 2, course 1, course 3. So we can return any order, right? So let's look at another example where there are 5 classes, right? So there is a really interesting algorithm that we can use. That's called the CANS algorithm. That's based, it's a graph traversal algorithm for topological sorting. Topological sorting is basically the correct ordering of the vertices that we can visit one after another. It's a graph, it's a BFS, right? Breadth first search algorithm, and it's really it was invented in 1960 something by Arthur Kahn. So it's this algorithm can really return the edge of the correct ordering of the vertices that we can visit one after another, right? So the algorithm basically says that we need to first initialize, that we need to build a graph, right? We are given this prerequisite class, prerequisite list, where from the prerequisite list we need to build the graph, right? This graph, we need to make sure that graph does not have a cycle. Cycle means, like we'll see in another example. Let's see, this we need to build this. We have this adjacency list. After adjacency list, we need to make sure which is the first course that we can take. We can take the first course, we can take it at course 0, right? Course 0, because this is called the in degree. We need to from the adjacency list or the graph, we need to build the in degree list, or the hash map, right? In Python is a dictionary. So first course that we can take is course 0, because it does not have any dependency, right? So if because it does not have any incoming edge, which means that it does not have any dependency, so we can take the course 0, right? Because if we can take the course 0, it means like it has this in degree 0, right? In degree 0. After we take the in degree 0, so we are done. So after we take the 0, so we just put the 0 to the list, right? Then what happens, then this is in degree. After we are done with this, and we break this rule, the edges, right? Because that 1 depends on 0, 2 depends on 0, 4 also depends on 0. We need to break all of these dependencies, right? Then this has only one edge was coming. It has only one dependency. That's why in degree is 1. Now after that we are done with the course 0, then we can reduce this one to 0, right? And this can also, we can reduce to 0, right? And we can start taking the courses that does not have any dependency, right? So the course 1 we can take it, right? Because it has in degree 0, because we are done with the dependency, right? Prerequisite course. So course 0 we are done, and then we take the course 1, right? After we take the course 1, then we can take the course 2, right? Because the course 2 doesn't have any dependency. Then we can take the course 2. Then after we are done with the course 2, after we are done with the course 1, we'll break this dependency. After we break this dependency, here it was when we are done with 0, then we decrement this one to 1, 2, right? Because it was 3, it has 3 dependent courses, right? Now we are done with 0. Then after we are done with 1, then we decrement this to 1, right? Then after we are done with 1, then we'll take the 2. After we are done with 2, then we also break this rule, then this one will be 0, right? After we are done with 2, then we can take the 3, right? After we are done with 3, we'll break this one, then it was 1, the in degree will be 0, right? Then we can take 4. So this is the correct ordering that we have to return. So there are a couple of concepts that we need to understand. First is in degree. In degree is basically number of edges that are incoming to the node. For example, for 0, in degree is 0. For 1, in degree is initially it was 1 because it has one dependency. Then after we are done with 0, the in degree, with like incoming edge, we decrement this, we decrease this by 1, so it will be 0, right? Whatever in degree is 0, we can start taking, we can just start putting them in queue so that we can take them, right? We need to make sure that there is no cycle. Cycle means like, let's say this example, right? The course 2, we have course 0, course 1, 2, and 3, and 4. So what is this? So we can see course 1 depends on course 2, right? And also course 1 depends on course 0, and course 1 also depends on course 2, which means like we need to finish course 0 if we want to do the course 1, and also we need to finish the course 2 if we want to do course 1. Same way, if we want to take the course 0, we have to finish the course 1. So they are like there is a cycle. There is a cycle between course 0 and course 1, and there is a cycle between the course 1 and course 2. So if you want to take course 1, to take the course 2, if you want to take course 2, to take the course 1. Like we don't really know like where to start. The same thing here between course 0 and course 4 is same thing. So only course 3 is basically free of as soon as we are done with course 2, we can take course 3, but we cannot really take any course 3 because we cannot take course 1 because there is a course 2 because there is a course 0 course 1 dependency, right? Basically what it means, in degree in here, none of the node has in degree of 0. So we can only start taking courses which has in degree of 0, right? For example, we can start taking, if we just can reverse this node this way, right? Not coming, if it's, we can reverse the node like this way. So then you can see there is no node coming in here, right? There is no node coming in here. So this 3 doesn't have an independence. So we can label as this one as 0. Then we can take this one and we can decrement this one to 1. We can decrement this one to right now this is not 1, this is now 2, right? Because there is one course dependency from course 1, another course dependency from course 3. So this is 2. So even after we take this course 2, course 3, we can decrement this one to 1. We can decrement this 1 to 1. Right now this 2, right? After we are done with 3, then we can decrement this 1. Even after we take the course 3, we cannot really take any other courses because none of the course except the course 3 has in degree of 0, right? Because like they all have a dependency. So then this is a really interesting algorithm. So we can review this. I made this mind map of this algorithm. So we need initially the core. This algorithm says that we need to initially calculate the in degree of all nodes. Means like we need to count the number of edges coming to the node, right? After we are done making that list in degree, or you can say dictionary or a hash map, then we need to add those nodes with in degree of 0 to q. So q is like, so we can start taking those courses, like whichever node is let's say whichever node is this is done, right? And after we are done with this, let's say this here, after we are done with the course 0, then we can start taking we can remove this all the dependencies, right? From course 1 and course 2. So after we can add those nodes with in degree 0 to q. Then we will check if there is any course in the queue. If we will ask if the queue is empty or no. If the queue is not empty, right, then we remove that node from the queue, right? Then because we can take that node, right? Because that node already has in degree of 0, which means it does not have any dependency. So we can remove that from a node. We can add that node to the topological order, right, to the list. Like after we are done with the 0, so we can add that to the list, right? Then we need to decrease in degree of adjacent nodes, right? So if there is a 0 here, it has 1. After we are done this one, right, after we are done this one, then we need to break this. Then so we can, this in degree of 0, this in degree of 1 after we are done with course 0. So then we need to decrease to course 0, right? Course of in degree 0. So we can add in degree decrease in degree of adjacent nodes. If the in degree is 0, that node after we decrease, then if it's 0, then we need to add that adjacent node to the queue. So because we can start taking that node, right? If it's not empty, then we just go back to if the queue is empty, right? If at the very end, if the queue is empty, then we say yes. After we say yes, we just keep processing all the nodes. Then here we just keep adding. Then at the very end, if the queue is empty, then what we'll say, then we return the topological order. We say topological order is complete, so we can start returning that specific the list of the courses, right? So this is a Kant's algorithm with topological sorting. So this is not something very difficult to understand. It's very intuitive, so we can use the BFS, right? So let's look at the code. So we are given initially we are given the prerequisites. Let's reduce this a little bit and change this. So we are given the prerequisites. Now we need to what we need to do. We need to build here the graph, right? We need to initialize the graph as a dictionary. Then we need to initialize the in degree. All the courses we will initialize as 0, right? Then with the number of courses, right? Then we say, okay, then we need to build the adjacency list as we built before. So to count, right? This is it's a list. First element is a course. Second element in the prerequisite is it's a prerequisite, right? That we have to take. So the course and prerequisite and the graph and dictionary a prerequisite, we need to add the course, right? Then we need to increase the increment to 1 of the in degree, right? We need to count how many edges coming to each node, right? Then we're gonna initialize here. We're gonna initialize the queue. The queue, how we gonna initialize? So we just go through the number of courses. Then if the in degree is 0, which means like that the list of courses that we can start taking, right? Then this is the order we return. Then taking courses, initially it's 0, right? Initially it's 0. So then after we build this queue with the list of courses that we can take, then we pop that. The first step, we can pop that course from a queue, and we can add that course to the order, right? Order list. Then we can also increment the taken courses, number of taken courses. We can increment by 1 because that's the course we took. Now, all the neighboring nodes of that specific course, for example, 0 and 1 and 2, all of the neighboring courses, what we do, we start exploring this, right? We start exploring all the neighbors of the course. This is let's say this is in degree of 1, 1, this is 0, right? Here we are decrementing this in degree by 1, right? This will be 0, now this will be 0, right? Then we'll see if those in degrees of the neighbors are 0, then we need to add them to the queue. Right now this is 0. Now we need to add them to the queue to process. So we can start 1 and 2. Now queue has 2 elements, right? Now queue will go back again and just starts exploring 1. It will take 1 because that's the in degree 0. So we can start taking this one. We can start also taking this one. So this queue is not empty. We just go back. We just do this again. And let's say this 1 can have another dependency. Let's say 3, right? And the 3 has in degree 1. After we start taking the 3, then we decrement this one to 0. Then we add this 3 to the queue, right? We just keep repeating all of this. We just traverse entire graph of courses that we can take in order, right? After we are done, after we exit this, we make sure that queue is empty. After the queue is empty, what we do, we check the initial number of courses, let's say 5, then taken courses, because we are incrementing this by 1. After we take all the courses, this should return 5. If we start with 5 courses, right? Then this should be returning 5. If this is equal, then we are going to return the order of courses, because we are adding all of the courses that we are taking in order to this list, right? Then if the number of courses equal to number of taken courses so far, then we're gonna return the order. Otherwise, if there is a cycle, as in this case, right? if there is a cycle, as in this case, we can take only how many courses? We can take only one course, right? Which is the course 3, right? We can take only one course, right? But initially we have 5 courses and we cannot finish it. If we cannot finish it, then we say, okay, we can take only one course, but we cannot finish it. So in that case, we are asked to return the empty list. So this is an explanation of the counts algorithm. So this algorithm is not only used for the course scheduling, but this is used in the task scheduling, and which task has other dependencies that we have to finish in order, if we would like to finish to see if that specific task has dependency, right? In which order we can proceed so that we can complete the entire task list of tasks one after another after we finish their dependencies, right? Yes. So this is a quick or thorough overview of this algorithm, and thank you very much for your time, for coming until the end, and I hope you guys understood. And if you have any question, please comment this video, and please subscribe and like and share so that it can support the channel. Thank you very much.